This conference will now be recorded.
Great. So dear friends, any question on top of your mind, if you have, please don't shy asking the question. And I'm just going to start giving you an overview of what is VXLAN. In this particular small journey of VXLAN, focused towards ACI, we are going to talk about the VXLAN topology, what is underlay, what is overlay, what are various overlay types. We are going to talk about VXLAN and its evolution, VXLAN terminologies, deployment modes, and one of the most important deployment mode called MPBGP EVPN. So we are going to talk about MPBGP. We are going to talk about EVPN. We are going to look at into the EVPN control plane. We are going to look at into what is there in between. So there is something which is imperative, something which is expected from you guys to know what is the BGP. We are not going to discuss each and every minute nitty-gritty of BGP, which is supposed to be there as a part of your CCNP enterprise infrastructure or routing and switching. Herein, we are going to talk about multi-protocol BGP using one of its address family purposely, and that address family is called EVPN. We are going to look at into the inside of it, and my dear friends, understanding MPBGP EVPN is very, very important to understand the internal working of ACI, application-centric infrastructure. All our labs are going to be based on MPBGP EVPN. Why we need to go to this topic? Why do we need to look at into VXLAN topology? Because the VXLAN topology is the one which is the predecessor of our ACI topology. So let's get started. VXLAN provides us a leaf and spine architecture. Cisco first time introduced this architecture in a technology called Fabric Path. That was Cisco's proprietary technology. Now Cisco is not at all propagating this technology anymore. You can say the technology is end of life, end of sale technology by Cisco. Now, but when it comes to the topology, even the Fabric Path was based on this topology, wherein there are two layers. This upper layer can be considered as an analogous to the core layer, and this particular layer can be considered as an analogous to the access layer. So there is no distribution layer, number one. Another important thing is in this particular architecture, well, let me tell you guys, this architecture is not at all a new architecture. This architecture is more than 3, 4, 5, 6, 7 decades old architecture. Well, first time this architecture was invented in 1938 by Edson Erwin, later on formalized by Charles Clos in the year 1953, and then adopted by the Bell Telephone Company. So pretty old architecture, but not in use now. Back again, old is gold, and thus this architecture of north and south connectivity only is being introduced. At the north position, we have our switches called as the spine switches. At the bottom layer, we have switches called leaf switches. The beauty is it is the connectivity only between the spine and the leaf switches. There is no connectivity between spine to spine. There is no connectivity between leaf to leaf. But in the lab number 2 of ours, we will connect leaf switches with each other physically, but logically we will make them as one single. So apparently there will be one single switch. This logical cohesion between the leaf switches is known as VPC, and I'm sure all of you guys know what is VPC. So practically speaking, the VXLAN provides us just north to south connectivity with no east to west connectivity. Point number one. All right. And not only that, there is another beauty which is called ECMP. Equal cost multipathing is what we do achieve with the help of VXLAN. We shall be talking about it. I will give you one question about this during the course of our discussion and would expect the answer. If not given, then before concluding the theory portion of it, I will give you the answer. Right? Question is definitely going to come. Now, the important thing is to understand underlay. Underlay is nothing but it is a relationship. It is the connection which we need to establish in between all the leaf switches and the spine switches using a routing protocol and the industry standard routing protocol. What we do use now is OSPF only. Dear friends, in case of ACI, in case of VXLAN, whenever you need any underlay to be established, we need to configure OSPF, and that too single area OSPF is well sufficient enough. With regards to OSPF, you all need to understand the nitty-gritty of configuring OSPF. For example, whenever we configure OSPF, we have to take care of point number one, MTU. We need to understand MTU mismatch can cause what and how to mitigate that. Another important type is the component is network type. While configuring OSPF, we need to look at into what network type. Besides having the OSPF, we also require in our underlay a protocol called PIM, protocol independent multicast, and which provides us the redundant capability by configuring rendezvous point. So dear friends, during the course of our VXLAN understanding, as I said earlier, we will give a pause. We'll move over to multicast, wherein we will understand all the nitty-gritties of multicast. And then we will come back onto VXLAN in order to understand the deep nitty-gritties of VXLAN. And that all will happen before stepping into the lab. Well, underlay. Another important thing which I would like to tell you about this topology is in the topology, since there is no lateral connectivity neither between the spine switches nor between the leaf switches, therefore there is no need of spanning tree protocol. Spanning tree protocol is completely bypassed. You know, one important thing which I would like to appreciate is whenever I say something, please do criticize by giving a critical response to it. Would appreciate that, because that will give me something more to tell you. So even in ACI, right, application centric infrastructure, since I know that you guys, some of you guys are working, most of you guys know about ACI. Even in ACI, we are using this particular topology. We do say that spanning tree protocol get bypassed, but dear friends, we should not at all think and assume that spanning tree protocol is not there. So even if in case by mistake we do this connectivity, spanning tree protocol is not available, it will not do anything. To be noted, in case if you physically connect the leaf to leaf or spine to spine spanning tree protocol gets activated immediately and will put one of your interface into a blocking state. So spanning tree protocol bypassed doesn't mean that it is not in existence. It will immediately get triggered the moment you will connect. You will physically connect leaf to leaf or spine to spine. There is a solution to this spanning tree protocol getting auto activated that we will be discussing in our ACI. All right, so back again on our underlay. Expectation here from you guys will be to know how to configure an underlay. And in order to configure an underlay, we need to know the IP addressing. That interface needs IP addressing, and I'm sure all of you know about it. We need to know the OSPF, and as I said, all the nitty-gritties related to OSPF configuration, for example, MTU, for example, network type, etc. When it comes to an NXOS, Nexus Operating System, there is a modification which is made by Cisco and which is definitely there in our ACI operating system as well. That is, with regards to OSPF, only two network types are available on a Nexus operating system. One is point-to-point and another is broadcast. Hope you know that Catalyst operating system or Cisco iOS has got 4 different network types for OSPF. Would appreciate now if you can tell me what are the other two types available for our OSPF in Cisco iOS. That will give some rest to my voice. Anybody? If you don't want to speak, you can type as well.
So can you repeat the question, please? I'm sorry.
Yes. My question is, when it comes to Cisco iOS, right? In Cisco iOS, for OSPF, there are 4 different network types: 1, 2, 3, and 4. 2 network types are these: point-to-point network type and other is broadcast. What are other 2 network types? And point.
One is the non-broadcast and broadcast.
Very good. NBMA, non-broadcast multi-access, and point-to multi-point in case of Cisco iOS. So anyway, right, NBMA used to be for the purpose of frame relay. Frame relay is now an obsolete technology. So Nexus operating system says that need not bother about OSPF network type point-to-point, multi-point, or NBMA. Only 2 network types. So this is with regards to underlay consideration. Guys, important thing. Before even stepping onto the VXLAN configuration lab, in case if you feel you need to brush up your knowledge with regards to OSPF and BGP, please do that in advance. And in order to support this, we have got, let me show you something. When I say that you need once you will join, you will get a login, and once the course will start, you will get the course assigned to you called VXLAN. And in the VXLAN course, besides having the class videos and the lab workbook, 2 lab workbooks available, you will get to download the PDF. This particular book called BGP by a gentleman, Sam Halaby, is a beautiful book on VXLAN. Would appreciate in case if you need to brush up your knowledge with regards to BGP concept, please go through this particular book that will be provided to you, and besides, of course, some other PDFs for the purpose. Okay, back on to where we were. All right, so setting up underlay definitely will be our task. In the lab, what will be pre-configured for you people? Just the IP addresses on the interfaces, some loopback addresses on the devices. But in case if we require some more loopback, we will be configuring that. So that will provide us underlay. When it comes to underlay, we have something called layer 3 interface pairing, IP interface configuration. The leaf switches are going to be called as edge devices. Below it, or you can call them to be as an access devices. Below the leaf switches, we do have our LAN segment, and connected to LAN segment, you will have the bare metal host, which are the physical servers. You may have the hypervisor based virtual servers as well. Now, the detailed concept of the hypervisor, the virtual server, and the networking between multiple virtual servers on top of single hypervisor or on top of multiple hypervisors, we shall be discussing in the topic apart from VXLAN, that is called ACI, not in VXLAN. But of course, the VXLAN also provides not only virtual machine communication, but also the physical. Okay. Once our underlay using IP addressing, multicast, OSPF as a routing protocol gets configured, then we will create our tunnels. Tunnels are known as overlays. Now, about the overlay, something which is very important for me to tell you is to understand what different kinds of overlays are there. Over here, just showing you number 1 overlay, network overlay, number 2 host overlay, and number 3 overlay is our hybrid overlay. Probably I will not be able to explain you over here in this particular slide what is network overlay. But if you see network overlay, the overlay is nothing but it is a synonym of tunnel. Which connects two different endpoints together. Dear friends, this terminology called endpoint, right, refers to tunnel endpoint. This is not the final endpoint. So I will use the term called tap. These overlays help to connect the two tunnel endpoints together, bypassing the involvement of all the devices in between, and we get a dedicated connectivity. Now, when this dedicated connectivity is established using the physical leaf switches, that is nothing but that is called network overlay. Now, in order to explain you what is host overlay, first of all, you can see that the tunnel endpoint has moved down. The tunnel endpoint is not available on the dedicated physical switch, but it is moved down. So the question comes is, what exactly is this? And in order to show you what exactly is this, I need to zoom this image. So let me zoom this image to tell you what exactly is this encircled one, and where are we? This one? No, this one, right? So guys, let me zoom the image over here. This one. Still we cannot see. Now further this, all right, it's coming, and this is 400% zoomed. I cannot zoom it beyond. So kindly be noted, earlier our tunnel and point was this particular device. Now it is being moved over to this. What is written over here? Hypervisor. And now on the top of the hypervisor, it is called VTAP. What exactly is this? This hypervisor and VTAP. This means on top of the hypervisor, there will be a virtual switch. So instead of having a physical switch, you may have a virtual switch, and on that virtual switch, we can configure our VXLAN tunnel and point. Dear friends, this comes to be as a concept applicable in our VMware solution called Nexus. So NSX, I'm sorry, not Nexus. In VMware, there is software-defined networking happens, and with the help of a solution called NSX. So in case of an NSX of VMware solution, we can configure our virtual switch as a tunnel endpoint as well. And then this is known as an overlay, host overlay. Now, there is a third type of overlay, which is called hybrid overlay, as the name suggests. In this particular overlay, one side we have a physical switch, on the other side we have a virtual switch. So this one is our virtual switch, which is configured on top of the hypervisor. Dear friends, in case if the concept of hypervisor, what is a hypervisor, what is a virtual machine, what is the server virtualization, what is network virtualization, is not clear, then I would strongly recommend you to go for the course called ACI. In ACI, we do discuss about server virtualization, the concept of virtual standard switch, hypervisor, and how this complete virtual networking is done. And not only that we discuss, we do it as well. Okay, so in case if your one end of the tunnel is physical and another tunnel is virtual, then this is called your hybrid overlay. So overlays can be of three different kinds: network, host, and hybrid. Now the question comes, what overlay we are going to work on? So my dear friends, we are going to work on our network overlays, where we will assume that we are having our physical switches, but in the lab we are going to use virtual switches because our lab is a virtual lab. All right, I can sense now you have some questions about. So anyone, in case if you have any question, any doubt right now, please let me have honor to address them.
Okay. So Ashish, I have few queries. So first thing is that you have explained all three methods. So which one is the best, or we can say which one has the more advantages? So if you can little bit explain on that.
All right, I'll say the hybrid one has more advantages, Because in case of an hybrid one, on the one side, you can have your dedicated physical switches, that is say Cisco switches, and on the other side, you can have your VMware NSX solution as well. But it all depends upon the customer's requirement. We are just providing the availability of all the three overlays. Suppose if a customer says that I don't want to go for the Cisco switches for the purpose of the connectivity, for the purpose of VXLAN, I just will deploy the servers. I will create virtualized environment in those servers and thus the VXLAN setup. In that case, definitely the host overlay is what which will be suggested. So all depends on the solution design, but what I'll say is the hybrid overlay is the one which I personally feel brings all the industry giants together, and we have more flexibility in it.
Okay. And in the case of host overlays, so from a network perspective, like on the switches side and all, so there is nothing special that we're doing it, right? It's just an L2 or an L3 connectivity, L2 connectivity which we are providing. Everything is happening on the hypervisors, VTAPs. So the switch is just acting like a plain L2 switch. That's it, right?
Yes, in a practical environment, what happens is, for example, the kind of environment where I have worked, these switches, they will be Cisco, for example, Cisco Nexus 9000 series, ACI spine and leaf switches. So what we will do is we will separate our ACI fabric with the VXLAN fabric. That is called network centric approach we will use in our ACI fabric, and application centric approach we will use in our servers, which means that wherever you want the VXLAN to be configured, you will deploy the servers, say Dell servers or any other vendor servers, and you will create the entire SDN solution there, the software defined application centric solution over there, called NSX or VMware SDN. And for the purpose of transport infrastructure, you will use your ACI spine and the leaf switches. Does it make sense?
Yes. But my doubt is, let's suppose if we're using NSX or something, right? So in case of host overlays, so then it really doesn't matter, right? That whatever we are using on a hardware switch side, even if we are using a plain switches, could be any Juniper switches or anything, right? So that need not have any specific requirements on hardware side.
You don't have a specific requirement.
Okay, got it.
Right?
Yeah.
Okay. Thank you, Harpreet, for asking this question. Guys, any other question? Caesar, we were missing you. Thank you so much for joining.
Yeah, sorry about that. Yeah, one of the questions I had was from a management perspective. So I think there's two ways of managing VXLAN. One is through CLI, and then another way is through the DCNM. Is there one that's more popular than the other?
Very good question, Caesar. Caesar, you are absolutely right. So DCNM stand for Data Center Network Manager, is Cisco's proprietary network management and monitoring tool. You can configure your VXLAN using DCNM also, and you can monitor it as well. Here in our lab, we will be using the CLI way and not the DCNM way. There is a separate lab if you wish to do it. I can provide you that lab as well for the purpose of running it through DCNM. Now coming over to the difference. Well, DCNM way is more simpler way if you are comfortable, unless and until you are comfortable with CLI. So I will say the DCNM way help you to avoid a lot of extra configurations because it does it automatically. But when you do the CLI way, in CLI you have to look at into each and every configuration and need to understand it. So that's the reason in our labs we are going to use our CLI way of configuring VXLAN. One more thing, DCNM, current version of DCNM which is running is 11.2 and Cisco has declared it end of sale product. Well, DCNM is now replaced with Cisco Nexus dashboard. So in case if you are planning to buy DCNM, Cisco will not at all suggest you to go for DCNM. Instead of, Cisco will suggest you to buy Cisco Nexus dashboard, and that too current version is 2.1. So you can make a difference. DCNM version ended with 11.2 when it comes to 12.1, which is known as Nexus dashboard. And you know what, I will give you hands-on onto Nexus dashboard as well. And in case if you want to do DCNM way, tomorrow in the class, VPC class, I will give you a DCNM look. So you have both the things with you. You know, Caesar, I'm not sure if I
Yeah.
increased your doubt or I cleared your doubt.
Yes. Yes. Thank you.
But tomorrow I'm going to give you a look on DCNM, right? What is DCNM and how it works? And if you really want to work configure, for example, VPC using DCNM, would appreciate you. Tomorrow I'm going to give you a lab wherein you will be able to configure VPC using DCNM. But I will show you how to configure using CLI. All right. Beautiful question, guys. Your question, they really energize me because univocal doesn't mean a lot to me. All right. So any other question on the way?
Ashish, other than this, like if we are talking about DCNM, so in that DCNM lab that you will be providing, so from in that lab, like is it something where the fabric is already created, or we can have like we can build the fabric from the start, like discovery and all, then do it from the beginning, or how's it?
Beautiful question, Harpreet. Really appreciate you for that. Yes, the lab which I will provide you, underlay, partial underlay will be configured, which means OSPF will be configured. OSPF neighbor relationship will already be there. Of course, before that, all the IP addresses in between leaf and spine switches will be pre-configured. The lab will just ask you to configure overlay, multicast, and complete VXLAN related configuration. But in case if you wish to configure from the scratch and you have the availability of EVNG with you, what can we do is can provide you the initial configuration which you can put onto this, or you can configure all the devices yourself starting from the IP addresses and then the OSPF and then MTU, etc. But in the before coming over to the overlay, I will show you the entire configuration and the nitty-gritty of it. Why I'm saying so? Because when you go to the, for example, any lab execution, that time you may tend to ignore the MTU concept, specifying MTU, and if you miss to configure MTU, your OSPF, that is underlay, will not come up, and no point of going to the overlay configuration. Okay, so I have given a long answer to your beautiful short question, and short answer to your beautiful short question is LAP will be pre-configured, IP addressing and underlay will be configured. No multicast, no VXLAN.
Understood.
Okay. Thank you, Harpreet. Thank you for asking this beautiful question. Guys, any other question on top of your mind, doubt you have? I'm not going to discuss more about the VXLAN. Lot many things are there. If you want to take a flash view of what we are going to talk about in VXLAN, definitely I can give you a flash overview. But before, your questions are most important to me. Now, so let me give you a quick flash overview of what we are going to talk about in VXLAN. We are going to talk about, as we were talking about, what is overlay, each and every terminologies with regards to overlay, like what is VTAP, what is virtual segment, what is LAN segment, what is virtual server, physical server, how the tunnels get created. We will talk about the RFC 7348. We will talk about RFC 7432. Then that was an enhancement to this RFC white paper. We will talk about why VXLAN. We will talk about the size of VXLAN, and we will compare the VXLAN with VLAN. We will see what was VXLAN earlier, what is VXLAN today, and what is the future of VXLAN. We will look at into various terminologies during the course of our discussion: underlay, overlay, VXLAN, VNID, VTAP, NVE, network, virtual endpoint, bridge domain, and VN segment. What are these? We will, underlay, overlay networks. And important thing, what we will discuss about, VLAN and VXLAN difference. Okay. One of the most important thing which we will talk about is to look at into deep inside a VXLAN packet by looking at into one of the Wireshark capture. Through this particular Wireshark capture, we will understand what are the various components involved inside VXLAN, and we will discuss about it, and then we will look at into the VXLAN frame format. We will look at into what component is replaced by VXLAN. We will look at into the further deeper inside the VXLAN packet, and we will look at into the very first field of our VXLAN header and the bit which ensures that our VXLAN frame is a legitimate frame or not. We will talk about the control plane and the data plane, overlay services, tunnel encapsulation. We will look at into the role of MPBGP. We will look at into the role of it's one of the address family called EVPN, how the peer discovery happens, what is route learning, local as well as remote, the route redistribution. This is to understand the VXLAN, MPBGP, EVPN deployment, and that requires a detailed discussion. A lot of terminologies will be there, and what else? Then comes the deployment modes, head-end application, flood and learn, MPBGP, how the communication happens, and the traffic flow, and the ARP request in head-end replication, and well, lot many things, and underlay, overlay configuration, and no end to it. And we will also see the difference in configuring VXLAN between Nexus 5K, 7K, and Nexus 9K. Because when it comes to Cisco Nexus 7K, VXLAN terminologies slightly they differ, the configuration slightly get differed. And however, when it comes to Nexus 5K and Nexus 9K, configurations are same. In Nexus 9K, all the models they don't support VXLAN. In Nexus 7K, there is a requirement of a specific line card which only supports VXLAN. So we will be talking about all those things as well. So, and then once our discussion about VXLAN, one important thing which is going to be a very integral part of VXLAN discussion is going to be the route type. And in the route type, we will be talking about the output of the command show BGP, L2 VPN, EVPN. Dear friends, this understanding is not important for VXLAN, but also very, very important for ACI. Those friends of us who are working on ACI, say single pod, multi-pod, or multi-site, understanding this particular output is very, very important for all those technologies. So we will be talking about all this, and that's all. I would like to give mic back to you guys. If you have any question, please feel absolutely free. I have got so many wonderful friends over here: Abby, Ajamil, Alex, Ayan, Mohammed, Caesar, Cicero, Islam, Harpreet, Sandeep, John, and another friend without the real name, and he's my best friend, New. And then we have got Pinto. Wow, Pinto, a name pretty well known to me. And we have Prasad, Leon, Syed Ahmad, Repov, and Tanmay Das. Guys, any question from your side? Please honor me to answer those questions.
Not questions, Ashish, but I can relate to the three deployment scenarios that you showed, right?
Yeah, Ajamil.
If you go back to that diagram,
Sure.
I can tell you like what I can relate to in the current network scenario that we operate.
Yes. I'm jumping over to that. And this is the one. Yeah.
This is the one, right? So like the network overlays. So network overlays, the easiest thing that which is possible is the having IPsec running IPsec VPNs or GRE within those, and any routing protocol like BGP or anything. So that is the easiest form of network overlays, right? In our network environment, we have those things. For the host overlays, what we have is one means our client has huge data centers, and we cater or provide services to end clients for our customers. So what we use is the customer has his data centers of Cisco ACI or Nexus deployments, and over there they either have, as you said, those Dell switches or HP Blade servers. So on those we are running OpenStack Cloud as overlay. So the end customers are not aware that what is running below, which is like ACI or the Nexus infra. What they know is their services are running on OpenStack Cloud, and they are just bothered on that, how their load balancing, application services, and everything is running on that. And for hybrid overlay, I think the best example in real-time world right now is like whenever we from our local data centers or or spaces, when we get services and build data centers over any cloud offerings like Azure, Google Cloud or so. So what we do is at our end we have our hardware, and the other end what we have is the over the cloud. So they would have deployed it over their ACI or any other infrastructure, and the where they host is, or where they build is their gateways, endpoint gateways. So their EPGs are all over the virtual or on the servers, and our side is on the physical router. So that is something like a hybrid overlay.
Correct. Right, Jamil. So is it the explanation or a question?
No. That's the explanation of the real-time scenario that
Okay.
we are encountering or supporting in the current infra.
Beautiful. So all the overlays types, they are very much in production based on the requirement. The overlays are set up. So absolutely right, Ajamil. Thank you so much for adding to the understanding. But we will be going for our network overlay configuration and understanding in the lab.
Right.
Right. Okay. Any other question, guys, on top of your head? If you have any doubt, any question? No? All right. Then thank you very much. Stay safe, stay blessed, enjoy the rest part of your day with work, and so do I. Thank you very much. Catch you people tomorrow. Bye-bye.
Thanks, Aziz. Bye.
Thanks, everyone.
Thank
Bye.
you.
Thank you.